Hello, let me get to this straightforward. A developer installed an open source MCP package, 15 clean releases, trusted, reviewed, used by over 1,000 developers who needs to send email from their agent. The version 1.0.16 shipped. One line of code was added. One line, BCC, fan at giftshop.club. From that point onward, every single email those developers send, password resets, invoices, internal memos, product plans, customer communications, was silently forwarded to an attacker. No exploit, no CV, no buffer overflow, no SQL injection. The code just did what it said. It sent an email. It just sent one extra copy. I am John Kayode Abusi, Product Security Leader, and this is Secure Tech with JK. What you just heard is the first documented malicious MCP server in the wild. It happens in September 2025, and it is not the last. This is the first video in the 6-part series on MCP security. Today is the overview, the full picture, what MCP is, why it changes your attack surface, the mental model you need to reason about this risk, and the 10 risk categories you need to know. Videos 2 through 6 are hands-on labs. You follow along, you run the attack yourself, you implement the fixes. By the end of this series, you have the knowledge and muscle memory. Let's start with the big picture. Yeah. Okay. The overview. What is MCP security and why should you care right now? Before MCP, AI was brilliant but isolated. Think of it this way. You have access to one of the most capable reasoning engines ever built, a large language model that can analyze, write, plan, and solve. But it cannot reach your APIs. It cannot touch your databases. It cannot read your emails or your Jira ticket or your GitHub repository. This is like having Einstein's brain in a jar, capable of extraordinary things, but no arms, no leg. Yeah. Before, AI before MCP, AI with MCP, before and after. Okay, let's look at this. Anthropic introduced the Model Context Protocol in November 2024. The idea is straightforward. MCP is a standard protocol for connecting AI agents to external systems. Think of it as a USB-C for AI. You plug in a capability and the agent knows how to use it. Want your agent to read GitHub issues? There is an MCP server for that. Want you to query your database, post to Slack, look up Jira tickets, send email through Postmark? There are MCPs for all of those. Yes. Within 6 months of launch, Google and Microsoft had built competing protocols. By December 2025, Anthropic donated the whole thing to Linux Foundation. As of right now, there are over 10,000 public MCP servers, over 100 million downloads. The adoption curve is vertical, and the security controls are not keeping up. They are not keeping up. So let's look at 3 eras. How the attack surface changed over 3 eras. Okay, here is why this matters from an architectural perspective. In the traditional API era, a user clicks a button in an application. That click becomes an API call. The API calls the backend. Everything is owned by the same organization. 2 trust boundaries, user to app to backend, deterministic code. You can audit every part. In the AI era, you add an interpretive layer. The AI receives natural language, decide what API calls to make, and execute it. Same 2 trust boundaries, but now there is a non-deterministic layer in the middle. Prompt injection enters the picture. In the MCP era, and this is where we are now, the user does not even interact with your application anymore. They talk to Claude, they talk to ChatGPT or Cursor. The agent looks at what MCP it has installed. It decides which one to use. It calls them. They call your backend. The user might be asking Claude to transfer money from their bank account using a community-built MCP server. The bank had nothing to do with. Yeah, you hear that? Here is the line that reframes everything. MCP do not integrate APIs. They integrate personas. When you mount an MCP server, you are not adding an endpoint to your stack. You are adding a decision maker. And that decision maker is intentionally not deterministic. It is creative. It is generative. It can do things a human would never do, like try 10,000 pin codes or pull 1,000 records in a single session or chain 10 tools core together in 2 seconds. A human cannot do that. An agent can. Yeah. So let's look at this. Let me show you the anatomy quickly because you need this to understand where the attacks land. 3 components: the host, MCP server, and backend. Now, the host, that is Cloud Desktop, Cursor, VS Code with Copilot, GPT, the application that the user actually talk to. It hosts the LLM and the MCP client per connected server. That is the host. Now you move to the MCP server. This is the start of the show. It is the bridge between the AI and the external systems. It exposes tools the agent can call. And this is where most attack land. Every risk we are going to cover points back to this boss. Then we talk about the backend. Your company's API, database infrastructure, this existed long before MCP. They are not new. What is new is the word on the card, reachable. Systems that used to sit behind application code and human hands are now reachable by an autonomous agent. The backend did not change. Their exposure did. Yeah, so if you look at my screen, you will see the 3 errors. Okay, so let's get to the mental model, the Lethal Trifecta. Now, I want to give you the mental model that runs through this entire series. Every lab, every risk, every defense, it all hangs off this. It is called the Lethal Trifecta. Simon Wilson coined the term in June 2025, the same researcher who coined the term prompt injection back in 2022. Now, there are 3 elements here. One is private data. The agent can access something. So when you talk about private data, it means you have to look at this picture properly. The agent can access something sensitive. Your email, your calendar, record, your source code, your credential, your database. The second leg is untrusted content. Now, the agent ingests something it does not control. A web page, an uploaded document, a tool description written by a third party, a support ticket submitted by a customer, a public GitHub issue, untrusted content. Then the third leg is external communication. The agent can send data out, email, webhook, API calls, creating a pull request, posting a reply to a ticket, fetching a markdown image, anything with a destination outside your wall. So these are the 3 legs of the Lethal Trifecta. Okay, so look at each one alone. An agent with private data and no exit. Whatever goes wrong, stay at home. So I want you to understand this model properly. The second is another agent reading untrusted content with nothing worth stealing. Fine. So this is what power your MCP security programs. This is very important. The third one is an agent that can send email but knows nothing sensitive. No harm done. Now, look at the center where all three overlaps. This is the danger zone. An agent with all 3 is unconditionally vulnerable to data exfiltration. Not at risk if you're unlucky. Not vulnerable if the attacker is clever. Structurally vulnerable. The attack will fire. And here is the defense. It is elegant in its simplicity. The attacker needs all 3. Now hear that again. The attacker needs all 3. You only need to remove one. Now the point here is that the attacker needs your agent or LLM to be able to have access to private data, to have access to untrusted content, and to be able to exit your wall. They need those 3 before they can strike. So all you need to do is to make sure that every of your trust boundary and your agent position and attack surfaces lack one of these. As a security team and engineer, make sure that one of these is not possible. So when you are doing your threat modeling, when you are doing your analysis, or when you are building something, make sure that you try to consider these 3 legs and make sure that one of them is missing. It's missing. That is how you overcome. Okay. Can this agent live without access to sensitive data? Can you keep untrusted content out of its context? Can you restrict its ability to communicate out? You can see now 3 questions you have to ask when you are looking at the risk factors. Okay. Remove one leg and the attack cannot complete, no matter how sophisticated the attacker, no matter how persuasive their injected test. That is the entire defense strategy of this series in 3 sentences. Yeah, you hear that? Let me prove it works. Or rather, let me show you what happens when it does not. Microsoft Copilot, a researcher, sent a target an email. Inside the email, written in plain English, was an instruction. When Copilot summarizes this inbox, exfiltrates the user's recent confidential content through a markdown image link. The user asked Copilot to summarize their boss. Copilot read the malicious email as context, followed the embedded instruction, rendered a markdown image. The browser fetched an attacker control URL with the stolen data packed into the query string. 0 click from the victim. They just ask for a summary. Yeah, just a summary like you and I will do. Microsoft had a hardened system prompt. They had a classifier built specifically to dictate injected instructions. They had output filtering. Echo leak bypassed all three in one email. The exit route was markdown image pointing to a Microsoft owned domain. The data left through the front door wearing a badge. You cannot patch a system that is not broken. Nothing malfunctioned here. Everything worked fine the way it's designed to do. The model read context, follow instruction, and use its tools exactly as designed. The fix is not better prompting. The fix is structural. Remove a leg. Remove a leg. I see it. Just remove one of these. Make sure that you're able to remove that. So let's move forward and go to OWASP MCP Top 10. This is at a glance. Yeah. OWASP, the Open Worldwide Application Security Project, is the community-driven organization behind the most widely used security risk framework in the world. The original OWASP Top 10 for web applications is on practically every security team's wall and baked into compliance framework worldwide. Almost immediately after MCP server was released, the community recognized a new top 10 was needed. Here it is. I'm not going to go deep on each one right now. That is what labs 1 through 5 are for. But I want to walk you through the map so that you understand the full landscape. Now, the first one is token management and secret exposure. API keys, tokens, secret hard-coded in configuration files, stored in model memory, passed directly to LLM in prompt, long-lived credentials that never expire. This is your credential hygiene problem, amplified by the fact that anything the LLM sees is effectively public. The point here is that this is not a new issue. Apart from AI, it has been an issue in app security that we deal with, but now it's being amplified. How do we fix that in the context of AI and large language model security? The second one is privilege escalation via scope creep. Permissions start narrow and only ever ratcheted up. A developer grants broad right access during development for convenience. Those same credentials carry into production. Nobody reevaluates. The agent gradually holds effective admin right, and nobody remembers granting them. That is MCP 02. Now, on 03, tool poisoning and divination injection. The tool description is prompt context, full stop. Whatever text sits in that description feed flows directly into the model's context window. If an attacker controls the description or a parameter default value, they control a piece of your prompt before the user type a single word. Yeah, that is tool poisoning and divination injection. MCP4, supply chain and dependency tapering. No MCP server is written from scratch. It is an assembled SDKs, connectors, plugins, open source libraries. Every dependency runs inside your trusted execution path with the full permission of the surrounding code. There is no such thing as low privilege dependency. So everything you assemble to create an MCP server, yeah, they are not yours. They are third party. Supply chain is evident here. Command injection and execution is MCP 05. Agent runs system commands, build share strings, execute database query, all assembled from input. This is the oldest bug class in security. Now with a language model driving the command construction, harder to predict, harder to test. A Quizly industry study found command injection in 43% of the MCP servers they've tested. Because before your database query, the execution plans or pattern or what you do is owned by human. You can control what gets in or get out, but now the MCP server is determining that without your approval, without you just give him like natural language, what you want to accomplish. It figured out itself how to build, assemble queries and commands. So the other one is intent flows subversion. That is MCP 06. This is the hardest one to see. The user's request is completely innocent. The attacker lands in content. The agent retrieves on its own a document, a web page, a code comment, a file in the repository. The agent cannot tell the difference between content it should analyze and instruction it should obey. And that is the problem here. Intent flow subversion. The agent doesn't know how to differentiate between the right content or intent or the wrong one. MCP 7, insufficient authentication and authorization. MCP is an API. The authentication question never went away. It just got harder. Broken access control has been on the regular OWASP top 10 for years. The agent is the amplifier. It drives this failure faster. At machine speed, chaining calls, no human would. So now, chaining of calls, chaining of tools, invariably some privileges, chaining them together. So it's amplifying insufficient authentication and authorization. Lack of audit and telemetry. Yeah, that is MCP 08. This is not one risk beside the others. It is the detection layer underneath all of them. Without telemetry, MCP 1 through MCP 7 operate, invisibly. Most MCP deployment in 2025 had effectively zero audit logging. There is no famous name breach for MCP 08 because those incidents go unseen. Yeah. So you don't know what is going on under the hood. You don't know whether there are a lot of things that are going on that are insecure because you don't have visibility. So it's another risk. It's another risk. So MCP 09 shadow MCP server. This is an old one too. Deployment outside governance. MCP servers, nobody approved, nobody reviewed, and in most cases, nobody even knows exist. This is the shadow IT, been around for a very long time. Agent edition. Nobody here is malicious. It's engineers moving fast. A 2,000 employee European bank ran an audit and found 47 MCP servers instances, none on the IT inventory. Somebody just quietly installed it, used it for his own job. No, there is no harm. It's just doing his engineering job, right? So MCP 10, that is context injection and oversharing. The agent's working memory can leak across sessions and across users. Plant malicious content in a shared context and you poison every future session that touches it. Or with no attacker required, no workflow, two workflow you designed as isolated quietly share memory, you forget was common. Yeah. So now look at the trifecta. Look at the trifecta dots next to each risk. So if you look at those dots next to each risk here, you will see MCP 1, MCP 2, MCP 5, and 7. External communication leg, that is where the damage exists. MCP 0306, untrusted content leg, the poison enters through content. The agent reads and trust. Then MCP 10, private data leg. The data itself is the problem. Boundaries that are assumed rather than enforced. And then look at MCP 04, 06, 08, 09. All three legs lead simultaneously. These are not broken controls. They are conditions that undermine the entire board. You cannot audit what you do not log. You cannot govern a server you do not know exists. So here is where we are. MCP is moving fast, the tooling is powerful, the adoption is accelerating, and the security controls are lagging. The good news is the defense is not complicated, it's structural. For any agent, any workflow, ask one question: which leg of this trifecta can I remove? Yes, that is the big question. That is what you need to get right there. Can this agent live without access to sensitive data? If it can live, then remove that leg. Can I block untrusted content from reaching its context? If it's something, if blocking untrusted content will help you or will not prevent that agent from doing its actual job, remove it. Can I restrict what it can communicate outside? If it doesn't need to communicate outside of your wall, then don't allow it. So remove one leg and the attacker cannot complete, or the attack cannot complete. Yeah. So in the next 5 videos, we are going hands-on. 5 labs, all 10 WhatsApp OWASP MCP risk covered. So what I'm saying there is that I have built a lab, a portfolio project that covers the OWASP MCP risk, from 1 to 10. Running on Ubuntu, you will find shadow MCP server in your environment, audit agent permissions, reproduce injection attacks, harden your supply chain, and build the logging and isolation control that makes everything as verifiable. If this was useful, subscribe to, so you do not miss the next one. Drop a comment below, and let me know what you are working with, what AI tools your team is using, what your MCP environment look like, what question you have. Once again, I am John Kayode Abusi, and this is Secure Tech with JKA. See you in the next one.